Part A, I'm going to take logarithms of both sides. I'll just use the basic log base 10. So that's taking log base 10 of the left-hand side, taking log base 10 of the right-hand side. I'm then going to use the laws of logarithms to bring the x to the front. And now I can divide both sides by log of 4 to get that x is equal to log 200 divided by log 4. If I put that into my calculator to 3 significant figures, my answer is 3.82. Alternatively, what I could have done is I could have just taken log base 4 of both sides at the beginning. That way these are inverse functions and cancel out. And I will just get x equals to log base 4 of 200. If you put that into your calculator, you'll get the answer 3.82 to 3 significant figures. So that's a slightly quicker way of doing it. Part B. Again, I'll show you both methods here. So, first method, I will take log of both sides. So log of 2 to the power 3y is equal to log of 84. I will use the laws of logarithms to bring the 3y to the front. And now I'm going to divide both sides by 3 times log 2. To leave me with just the just the y on the left-hand side. And if I put that into my calculator to 3 significant figures, I get 2.13. Alternatively, I could have taken log base 2 of both sides at the beginning. That way, these are inverse functions and cancel out and just leave me with the 3y. And then divide both sides by 3. And put that into my calculator to get the answer 2.13. Question C. Again, I'm going to show you both methods. We'll take log of both sides. I can then use the laws of logarithms to bring the whole of the 2 minus z to the front. I'm then going to divide both sides by the log 6. So 2 minus z is equal to log 400 divided by log 6. And now if I add the z to both sides and subtract the logarithm terms from both sides, that way I will get z as the subject. And putting the left-hand side into my calculator, the 2 minus log 400 over log 6 gives to 3 significant figures minus 1.34. Alternatively, on my calculator, I could have done log base 6 of both sides. These are inverse functions, so cancel out. I will then add the z to both sides and subtract the logarithms from both sides. And typing the left-hand side into my calculator gives me the answer minus 1.34. Moving on to part D now. So let me just get myself a bit more space. Again, I will show you both methods for part D. So, taking logarithms of both sides. Using the laws of logarithms to bring the 2w minus 1 down. Making sure you keep that in brackets for now. I'll divide both sides by log 3. Add the 1 to both sides. And then finally divide both sides by 2. So w is 1/2 of log 4 over log 3 plus 1. On my calculator to 3 significant figures, I get 1.13. Alternatively, I could have done log base 3 of both sides at the beginning. These are inverse functions here, so they're going to cancel out and just leave me with the 2w minus 1 is equal to log base 3 of 4. Add the 1. Divide both sides by 2. And if we put that into our calculator, we will again get 1.13 as our answer. Doesn't matter which method you use for these questions. This method here is the more general that will work for a wider variety of questions. For example, if we've got unknowns on both sides, this is often better, or powers on both sides rather, but it's slightly longer. This method over here is slightly quicker, but won't always work. It's good to know both.